Okay, I changed the drop-in point to -2 and the learning rate so that the next sample is exactly in this minimum. As a result, the minimum is immediately reached, but we don't have enough samples to make a 4th degree fit, so we need an extra sample. That sample is then on the other side, so -0.2. So jump somewhere here. And a lot happened. It now fits a cubic through 1 and 2. So next we would jump to this point, the maximum. The maximum of the cubic. But since this is a local extreme, it should have fitted the 4th degree polynomial, which would be an exact fit, and then it should have jumped to the exact maximum. And that's what I'm going to work on. So why did that not happen? In fact, it did. Fit a 4th degree polynomial through the 3 samples, the extra data and the starting point and the minimum. And this shows then the maximum at 0.68. So that would be there. And this is the 4.16981 is this minimum here. But we are looking for a maximum, so why is it not jumping to this value? Yeah, I think that what I see happening is that it just adds the extra point. I do want to call this, by the way. So this is the extra point, extra sample. And I do want to call that. That then returns disconnected, but I should not really care. Don't think I care about that. I mean, if I go into the reset stuff, then more or less belongs to it. And yeah, I don't want to do this. It's just the cubic fits through 1 and 2. I want to see the point where we return from this function, I think. Yep. Yeah. Well, let's just start here. I'm going to put a breakpoint here and then stop when we minus 0.2 is being passed back. Oops, already had that. Okay, there it is. Call to minus 0.2. Let's add it to the history. Okay, so here the handle local extreme is being called, and I would say that it has to return the point that I want to jump to. I'm just gonna do next, I think. So the best 0. What? 4.1 is? Wait a minute. That's a minimum. We should be looking for a maximum. Nevertheless, that seems to be the return value. Did that end up in this variable? Yes, it did. So finding the best 0 went wrong. But ignoring that, we then should jump to that value. However, that is now stored in W0. Which I'm not using, so yeah. What happens after that? Yeah, maybe you can do. Maybe you can allow this. I'm not sure. I think actually, probably I can allow this. But now I want to return and use the value that was stored in the W0 value. W is now equal to, it's still equal to minus 0.2. Why is that? Because yeah, next. This one is going to update it. So I don't want to call this function. I just want to set W now and then return, or yeah, and then just return. Line 90. It's not a state test, is it? If something. Hi there. It's a bit difficult to explain, but it's finding a minimum, a local minimum in a function, and well, one that has, if it has minimum on the left and the right, then those must be higher. No. It's on GitHub. See the description. It's in a machine learning project, part of. So if that is not the case, okay, then when we get here, yeah, this assert doesn't fire. But then this is the point where I could return false, just to show that we did have a 0. No, we don't have a 0. Wait, if I return false, we did not have a 0. Otherwise, yeah, we would. So, but if I return false here, then what do I miss? I would miss these last few things. Age restriction being set. It could already be set, I think. Oh, I don't even care about it, actually. Wait a minute. I do care about it if I return false. Yeah. Last extreme explored H direction. I have to do that as well. This is so weird. Why would I sit? Oh, wait a minute. But I don't want to do that in this case. Or do I? I could return false and then... Okay. Maybe... I don't have to do this, let's put it that way. Seems that this is the only thing that we need to do. Really hate code duplication, but in this case I'll make an exception. I have a Discord, but so far everyone who said they would help me they just disappear again. But you're free to try to compile my project, and then if you have questions about the project itself, then I will help. Yeah, I already answered that. I copy this as well. Yes, true. I can remember that result. And then I want to use that here. Say have 0. Hey, Ellie. Yeah, nice, isn't it? So normally this would return true if we find 0. Yeah, and then we just use this here, which means a few things. It means, of course, that the state must be equal to that, and that, yeah, basically W is unequal W0. But then again, it could be equal. That's why I would rather use this boolean instead of testing that. On the other hand, if by coincidence they would be the same, then actually I do not want to return this, and I just want to fall through anyway. Because then we already have the sample. So that would be kind of coincidence, but okay, let's check that. So let's say have 0 and not is negligible. How the hell do I write that? Part of scale, so I need my scale here. Now I can finally actually explain something. If the one that wanted explaining is still there, Aksat. So we want to find the minimum of a function, this function, which happens to be a 4th degree polynomial in this case. Just a test. We start at a random point, and the only thing I have is the derivative and the value of that function, so this height here. And we want to find a minimum, so we're going to the right because the derivative is like this. And then we did more or less a random step, and that is then equal to the derivative minus the step is equal to the minus the derivative times some random constant, usually called the learning rate. And I just deliberately set the learning rate such that it will jump by coincidence between thread quotes to exactly this minimum to test something. Yeah, so as a random step we jump exactly to the minimum, and then a lot of things happen because yeah, so the normal gradient descent algorithm basically, and then it jumps from -2 to -1.1, 007, which must be very accurate. And as a result, we then discover that if then we do cubic fit, then of course the fit has a minimum in the same point because the derivative is 0. I mean, the fit is based on the derivative, so the fit has the same derivative in that point. In other words, it discovers that it is already in a minimum, and it wants to jump to the minimum. But yeah, it's the same value, see? So I force it to go to something that is almost exactly equal to the minimum already anyway. So the absolute step value is 2.5 times 10 to the power -5, and then it says, yeah, minimum reached, because it's just the step size is so small. It stores a new extreme. Well, I mean, we found it, right? So it stores the minimum, and because it is a minimum, it sets best minimum to the same value. The next extreme type is toggle to maximum. Now we're going to look for a maximum. And yeah, now we have only one sample apart from the extreme itself, because I jumped there immediately. So we have only this sample plus the extreme. So there's only one sample here and the extreme then. And that's not enough to, it's enough to fit a cubic, this one, but not enough to fit a fourth degree polynomial. So I want to have another point, and that other point is then crafted by adding this distance to this point here. So we get, yeah, ploing, ploing. We want to have an extra sample here, so the height and the derivative at that point. And then return into the same function, handling this local extreme, which then is going to fit a fourth degree polynomial through those 3 points, which then is exactly equal to the function, because the real function is, the function on the test is a fourth degree polynomial. Ah, this is wrong. Just, I don't know, random title that somehow called there. And we want to go to maximum. So what should happen is that it now jumps to this point here. But there are still several bugs. And we call them here. Well, assert. State equals need extra sample field. So what happened? We return to minus the point where we want the extra sample, then we get the extra sample, value and derivative. It's added to the history. And then we re-enter handle local extreme, because the state was need extra sample, so this is my extra sample, so we want to re-enter that the function that was asking for the extra sample. And now we have enough samples. Then it can fit the fourth degree polynomial using the extreme and the first sample and now the extra sample. And then this is the actual function. So it's a very nice function, as you can see, which has a 0 there and there. And we should jump here because this is the maximum, but it jumps to the minimum. So that's a bug. At least that's what it should do. Seems we're still inside algorithm update approximation. You can see that by the indentation. Although the quorum starts here. Tja. Oh, okay. So have 0 is set. That's what I wanted, and we are showing it's totally not negligible. W was the entry value, is was minus 0.2, and then the W0 is well 4.169. Yep, this is definitely not negligible. But my state has been set to done already. I had not expected that. I can just remove the assert, but maybe I just don't want it to be reset to done. Oh, I'm doing that, yeah. Yeah, I guess I'll just remove the assert then. Otherwise, I would have to explicitly not change the state if F0 is set. Which is kind of stupid, because that would be only to avoid this assert, which is, in other words, the assert is wrong. Okay, so again, jump to this minimum and then add another sample, and now we jump to 4.169 here. Or we don't, because the columns again still well asserts. To its critical point is unequal local extreme. Yeah, okay. That's because the jump is wrong. I think at this point it understands that we want to get closer to the maximum here, but instead we completely jump over it, so that's not correct. Hello, Alman Kumar. I probably should first look into why the hell it is returning this instead of the other 0. Next extreme type is maximum. I don't know. Definitely not immediately clear. Okay, let's stop immediately after printing that. That's not after, that's like on top of it. No. Okay, so we have 2 zeros, obviously. You get both zeros. Now we get the function value at those points. And here determines the best 0. What a bullshit. What a bullshit. Yeah. It's only looking at H direction. That's interesting. So both zeros, this one and that one, are both on the right of where we are, and we're going to the right, and then it picks the best 0 as being the one that is the lowest, skipping the whole maximum altogether. But I don't want to do that. That's only for deciding going left or right. So this is not correct. Apparently the indexes say something about left or right. So maybe we can just print them. Expected 0 zeros. We can just do 0 0 0 0 and 1. So I guess that index 0 is on the left and 1 is on the right. That's complete nonsense. Complete nonsense. So because h direction equals right, we are going to the right. It picks the rightmost 0. That is nonsense. It's just totally not taking into account that the two zeros can be of different type. This is a maximum, this is a minimum. If that is not the case, then there are left and right of the current point. So if this was a maximum, then we have a minimum here and a minimum here. This is a minimum, then we have a maximum here and a minimum here and a maximum there, left and right. So as soon as the type is different, then they will be on the same side. And then I don't care about the distance. I just want to jump to the type that I'm looking for. Which should be, well, they alternate. So we are in a minimum, then the nearest one will be a maximum. And that will be the one that I'm looking for. So I don't even really have to look at if they are a minimum or a maximum. And if they are on the same side, I just want to have the one that is closest to where we are now. No. This stuff happens in line 433. So it is always set in returns index 0. Unless we have 2 zeros, then it could be a 1. And 1 is then the leftmost 0, which is correct in all cases except the one that we just ran into. If h direction is undecided, then still we don't want to do this. No. Still would want to have the nearest one then, I think, because that would be the right type. Yeah, let's rewrite it. Let's rewrite it. Int best 0 equals 1, 0 I mean. And then we do if, and then we do stuff. It's always 0 if, unless, like I said, number of zeros equals 2. So there is absolutely no reason to even do these calculations in that case. Oh wait, it does, because I'm immediately using it. Well, else assign this thing. So this is also 0. Don't have to call it bis 0. Yeah, and then here I can do another if. If our case, otherwise old case. And this then has to compare we have to compare with the zeros value. Compare with zeros 1 and 2, 0 and 1 I mean. Equals something's less than, or what is it? I don't know, something larger than, and then this here must come the same thing. That is then the current minimum. Do I have that is the question. Yeah, yeah, I should have that. I'm pretty sure of that. It should be this value. Okay, now it should jump to the maximum and hopefully the assert will go away as well. Yep, that works. So now it did fit a fourth degree polynomial through these three, and that is this thing. And then it jumps to the nearest extreme, which is this maximum. Nearest compared to that one, I think, yeah. And then we have immediately also a reset cubic fit, which goes through 2 and 3. That's nice. That's what I want to see. So now we're going to look for an extreme of this cubic on the right side, which doesn't not exist. Therefore, it's just going down, 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 down. So it should just take another step. See, you can see that already. Should have done that. Oh, again, sorry. Takes an extra sample. This is again a local extreme. And we did a reset of the relevant sample, so we have only 2 samples now. So we must need we need an extra sample, which is this one. And now it fits the fourth degree polynomial again. And then it should jump to the, still to the right, to the nearest extreme, which is now this minimum. Or we crash. That's the same one as before. Well, it does correctly return that point. Hoping we have a fourth degree here. So I'm getting the 1.5 as the extra sample. And the local extreme with that, fitting fourth degree. Okay, yep, using these points. That would be 2, 3, and 4. Now these three are being used. For that, same approximation, of course. Same zeros. Now the best zero is 4.17. So, okay, very good. Update approximation is called, because that returns disconnect whatever the historically set. I fit the cubic through the new points. These two. Extremes out. Okay, whatever, yeah. Oh, there is a minus 16. It's not, the drawing is not updated, so I can't really see it, cubic. Right, anyway, it is returning the global minimum already. Yeah. Well, that's interesting. So apparently the new cubic fitted through 4 and 5, which is going to be added here, but not visible yet. That cubic has a critical point, I guess a maximum. It must be something like this and then up. Or, no, wait a minute. Must be something like this. No, I don't know what it is. But it has a maximum in, oh, minus 16. Yeah, okay, sorry. Maybe something like this. So you come from come high here, I guess, and then you fit here horizontally. So this is the minimum, and it must go through 4. And then at minus 16, it has a maximum, which is, of course, has nothing to do anymore with the original line function. And the critical point has been set to minus 16. Maybe because that is the maximum, and we are looking for a maximum at this point. Still looking for a minimum here. Yeah, at any rate, we came from 1.56, this point, and we jumped to 4.17, this point. So go to the right there. And that is going away from the minus 16. And then I assert, because you would expect that the current state of the algorithm, it should have gone towards it. But the reason that it went this way is because this is the minimum of the 4th degree polynomial. And that has nothing to do with whatever cubic we fit. So that the cubic has a maximum at minus 16, I don't care. This whole test should not have been done, because we just jumped to a 4th degree thingy. Basically, assert is wrong, or you could say the critical point should have been equal to that point. I think it's a good question to ask where the critical point is being set, and if it shouldn't have been set to this point. So we'll look at the source code, 352. Or not. This is in skill.h. 352. I don't think we get here. Maybe I do actually, because of the reset. Did not see more than 2 relevant samples yet. Yeah. You know what? I'm going to delete assert, and then I guess at least we get an update, a graphical update, I hope, of what is going on. This is through 5 and some point that was added here. Maybe I went too far. This is through 3 and 4. I don't see anything at minus 16, I must say. This one has a maximum here and a minimum here, which looks very sane. Yeah. No, it's storage should be useless. Really? Well, that would be weird, Mark. Hmm. Anyway, this thing, right? Yep. Jody, can you tell me, oh, wait a minute, the root. Yeah, I'm not interested in root. I'm interested only in the root of the derivative. So the extremes. Yeah, let me have a quick look at. Quit. Yes. No, those are the roots, I think. You have to take the derivative. Wait a minute. Yeah, this thing should have only two extremes. Take the derivative and then the root of that. And one of them is going to be 4.17. I think I'm going to take a break. a brick. I'm too I don't know, dazed or something like that. I can't think. What the hell the reason is here, I have no idea. Makes no sense that this value is only set here when this is when more than two relevant samples is false. Does not make sense. Oh, not even returns then. Hmm. Yeah, I don't know. I can't think anymore. Let me quit. We'll just lose a game of chess or something. Maybe that's why I lose always with chess when I play here online. Because I only play chess when I'm totally tired and I can't code anymore. Very annoying. Hmm. Trim it. Just set a green here. Yep. Hmm. No, I should have played the pawn. This is losing. Damn it. He has an infinite number of... You just have to run. I don't know. I can't do anything else. Then I lose this one as well. And I lose everything. Dude, you gotta be fucking kidding me. At least I know I have tempos, but... Maybe... Maybe... Oh, now I win the pawn. Thank you very much. Now I win the game, maybe. Mm-hmm. Oh, it's my move. Yeah, I already... Yeah, very well played. Lost as usual.